Rank Xerox is a company that's been through the complete cycle. It started from scratch when Xerox and Rank first formed the relationship back in the late 50s, early 60s, and we have seen it having sensational growth. It's reached maturity, and it's now finding growth much more difficult to achieve. As a company matures, competition tends to come in. The shareholders then tend to get less of a good deal than they had before, unless that company can show that it can cope with the change in its market environment.
To photocopy has become by definition to Xerox. And for the last 20 years, the odds are that the copier in your office was a Xerox machine. But in 1972, their patents ran out. Rank Xerox and the Xerox Corporation were faced for the first time with real competition.
Hello. Hello. You've brought it now, have you?
Yes. Do you have anything you'd like us to copy at all?
Yes, please. Could you do me half a dozen of those?
Hello. Come right round.
By the early 80s, their market share had collapsed. In the middle product range, for example, from 70% down to 25%.
We had all the advantages of an invention, which gave us a very clear lead in the marketplace and what turned out to be an extremely profitable market. So, therefore, it's not surprising that we attracted a lot of competition. The Japanese were very firmly established by the mid-70s, and we found our market share eroding very quickly. We'd also, as you would expect, unfortunately, become complacent and slightly unwieldy, used to living in a fairly lavish way. We made a lot of profit. We plowed a lot back into new products, but we were still not efficient, and we were running rather fat.
When the Japanese first entered the market, they discovered a need that Xerox had never fully investigated. Small, cheap desktop copiers. Today you can walk in off the street and choose from half a dozen.
Visually you can see how compact it is. It's got zoom lens.
Their marketing strategy is to find out, even anticipate, what the customer wants, and then meet that need as economically as possible. Cost of ownership, delivery, reliability, all became part of the quality equation.
It's a very simple, well-designed machine, very compact. I think it's a winner.
It took us a little time to realize that this was not a manufacturing problem or a design problem or a development problem. It was, in fact, a company problem. And that when we started to look at quality and what the customer wanted, and this was the important thing, we didn't look quickly enough at what our customer wanted. We made all sorts of things that we thought were super. And we tended to go to the customer and say, look at this marvelous box we've got for you, without really finding out what he wanted. And it was only when we got to customer requirements that we realized that we had not a quality program, a total quality program from right throughout the company.
Competition has taught Rank Xerox the importance of providing products that meet the needs of its customers. But to do this, they've had to examine all of the processes that go to produce those products. There are two very important ideas behind their program of quality improvement. The first is the idea of control. To manage any process properly, you need to know exactly what you are trying to achieve and that the process you are using is capable of achieving it. By measuring the outputs and comparing them with your standard, you can monitor the way the process is performing. Some small random variation is natural in most complex systems. Extreme readings or unexpected patterns of measurement can be useful indicators of fundamental problems. The crucial thing is to feed this information back so that it can be used to adjust the inputs to the system and so bring the whole process back under control. Though, of course, all this information is only as useful as the response that is made to it. The major physical process in the manufacture of a sophisticated modern product is assembly. Thousands of individual actions have to be coordinated so that each feeds the next with a part or with a sub-assembly that can be built up into the finished item. Using this idea of control to manage complicated processes so that they operate within known overall limits is an essential part of Mitchell Dean's total quality program.
In the 60s and early 70s, it was very much a matter in manufacturing industry, in Rank Xerox as well, of inspecting quality into a product after manufacture. Most manufacturing companies, including our own, had significant rework areas where product that was less than it should be was reworked and before sending on to the customer.
Here, where they once tried to inspect quality into their product, they now control the assembly processes that put together their answer to competition in the small copier market. The same models are also made in Japan by Fuji Xerox, a joint venture set up with Fuji Photofilm in 1980. In fact, they were designed by Fuji Xerox, and most of the components are made in Japan. Comparisons of defect rates and productivity levels between assembly operations here and in the Japanese plant show that today Mitchell Dean is at the very least matching Japanese performance standards.
In the late 70s, early 80s, we started doing business with Fuji Xerox in a customer vendor pattern. We started sending product to Japan, large, expensive products, and we had a cultural shock. Fuji Xerox refused to market the products that we were sending them, and these were products that we were sending into our own marketplace successfully, profitably. It rather put us back on our heels, and we had some teams over from Fuji Xerox examining our process, giving us advice. Subsequent to those visits, Fuji Xerox then, after a few months, started receiving our products and shipping them directly into the marketplace in Japan without further inspection activities. We did learn a lot, and we did, in fact, improve a lot over that time. Since then, we've moved on an awful long way, and Fuji Xerox have, in fact, sent people over here to learn how we are now so successful ourselves.
Success depends upon having a process that can actually do what you want it to. It begins with a product design that is both responsive to the needs of the final customer and to all available manufacturing resources. The whole operation is affected by the people who work it, by the design and the layout of the lines themselves, and by the timeliness and quality of component supplies. The aim is to devise a system capable of operating within very specific limits, and to be able to measure each of its very many different elements and activities to just that degree necessary to ensure its overall performance.
If you were here 5 years ago, you would have seen an area where 100% inspection in the lines. You would have seen a lot of goods and goods inspection, where all the parts, in fact, were inspected before they come in. Looking at the situation now, we, in fact, rely on the vendors with certifying components to guarantee and assure that the components we receive are good. And we also apply the statistical techniques to sampling of the machines and the inspection processes we have on the line here.
100% inspection at the end of an assembly line, rework and rectification. The constant need to weed out the good from the bad in incoming supplies. These are all ways of coping with uncontrollable processes. Most of industry is reluctantly learning that the only answer is the difficult one of building control into the process. Do that, then as long as incoming parts and materials conform to specification, defects in the finished machines will be down to parts per million. The assembly process is monitored at these control stations. Judging where best to put them without unduly interfering with the overall operation, whether the sampling of defect levels should be the job of the operator or of a quality inspector, just what to record and how will all depend upon the nature of your business and its management style. Here, everything seems to be under control. But But what if you want to make substantial improvements to a process, to obtain performance levels that better suit you or your customers' requirements? This brings us to the second idea. Improvements don't just happen. Change has to be managed in a systematic way. First of all, you have to establish where you are now. Then decide where it is you want to get to, how you'll be able to measure any improvement, and how you will know when you've reached your objectives. The next stage is to generate alternative ways of getting there. Perhaps the most difficult part is that of evaluating the alternatives so as to be able to select the most promising route. All that remains then is to implement the changes you've planned, monitoring your progress as you go, and taking corrective action whenever you find yourself deviating from your chosen route. Of course, none of this works unless the people involved come along with you. Having reached your objectives, the concept of control takes over again until you decide to seize another opportunity for change, or until outside circumstances force you to move on to a new destination. By using this kind of structured approach to problem solving and improvement, and by introducing the idea of process control into every area of their operation, Rank Xerox's Mitcheldean plant has taken a leading role in the company's development of a total quality program. Mitcheldean isn't only an assembly plant. They also manufacture parts, using processes that may appear easier to control than those of assembly. Machine settings can be very exact, measurements precise. But parts like these pressure rolls being made here for a copier that's assembled in Holland are particularly critical. Improving these processes is as important a part of total quality as being able to control them. First, raw steel castings are bored at each end to house the bearings that will be fitted at the very end of the process. Then they are turned with a very slight profile along the whole length of the roll. The middle must end up just 1.5 thousandths of an inch thinner than the two ends. After grit blasting to key the surface, each is sprayed with PTFE to give a Teflon coating. Then baked and sprayed again 3 times. To restore the original profile, the whole bar must be turned again. The final coating must be complete. No spots, holes, cracks, damage, or any variation in its overall thickness. The design specifies no defects, so inspection at this stage ensures that only acceptable rolls go on to be completed. Yield from the process was running at about 85%. That loss of 15% of production was costing the company around £70,000 a year. So a team was set up to investigate the problem. But first they had to come to clear definitions of the differences between the various kinds of defects they were getting.
A classic simple example would be one inspector or one operator would think that a hole, because that's caused by a specific machine problem, one would call it a hole, but another person would call it a damage. And therefore, it would depend which one categorized it. It would either go in the damage bag or the hole bag. Mm-hmm. And that's obviously total confusion. So clearly we had to set about to set the standards for the actual types of defects.
By gathering information about the different kinds and levels of defects, and by careful daily observation of the way each part of the operation performed, the team began to try and understand in detail the process they wanted to change.
We knew we had very many variables, and there was a general lack of understanding in some areas of the process. But we did get together, and we evaluated the types of defects, and that was used in the Pareto analysis concept, and came up with 80% of our problems were in 4 areas: holes, thickness, peeled edges, and spots.
These 4 main problem areas could all be traced back to the PTFE coating stage, an intrinsically difficult process affected by many factors. The rate and distribution of spraying, the consistency of the PTFE itself, cleanliness, baking temperatures and curing times. Each affects the other, and small variations in any one of them can upset the whole process.
In the middle of all this, it was during the summer, and it was very hot. And in the particular area where we spray, it gets very warm, very humid, and we went down a number of avenues trying to overcome this by improving ventilation, checking the humidity, temperatures, see if we could control them by any way. After a lot of effort, I don't think we were able to achieve an awful lot down those avenues.
No.
But
I think an awful lot was done with very little breakthrough initially for the first 2 months. So we done an awful lot of work with no specific breakthrough to improve the quality or the yield.
No, we treated a lot of surface problems instead of getting into the core of the problem. You know, it was the ones that were sort of blinding us initially before we got really into where we wanted to go.
That's right.
No, I wouldn't think so.
It was 6 months before the team achieved the kind of consistent improvements they were looking for.
When you go back over it, it's very easy to...
Results came slowly as one small breakthrough followed another. Changes in PTFE handling and use. Slight changes in its composition. The introduction of filters inside spray guns. Alterations in oven temperatures and in the way they are measured.
Although we sat down around the table each week, a lot of the work was done on the shop floor. It was sort of detailed monitoring, observing, analysis.
You get ideas from other people, you know, just
Yes.
you know, sometimes you can't see the wood from the trees yourself, so you get ideas from other people and you sort of build on those. And sometimes you can come up with some good ideas.
I think the specific one actually was the inspector saying, well, we know that these rolls turn better if you hold the rolls for 24 hours and then put them through turning.
Yes.
We actually did achieve better results, but we really couldn't define why.
No.
There's no specific
It's an
reason
important
why.
point, really, because whilst we formed the team and the basis to control, identify and introduce the actions, etc., and monitor the effect of various actions, which Roger did in particularly on a daily basis, clearly major benefits came from the people on the shop floor themselves.
At the end of 6 months, yield was up to 95%. And though the team are never quite sure they couldn't increase it by a percentage or two, the emphasis has turned again to control, to maintaining the process at its newly established level. At Mitcheldean, they began by concentrating on the control and improvement of existing processes, and then on managing the design and startup of new ones. Measured by the conventional categories by which companies usually cost quality, scrap, rework, cost of warranty, and so on, the results have been impressive.
Quality pays for itself. And I would say that we have reduced the cost of quality, that's the cost of poor quality, in this plant by over 50%. And that means several $1 million.
But what if you could introduce these ideas into every area of the company's operation? Treat the activities of each individual and of each working group as a process, with outputs and performance levels that can be monitored and improved. At Mitcheldean, they believe that you can, and that the potential benefits are enormous. And the Xerox Corporation worldwide is beginning to catch them up.
The most fundamentally different approach for us, I think, as a marketing entity, is the recognition that everyone within the company has a customer. We all have internal customers.
Hello, 391.
There's some very different facets. Probably the most significant one is if you're in a production environment, you have the ability to measure very precisely the items you produce. In a marketing company, whilst there are some activities that you can measure, for example, producing invoices, you can measure the accuracy of those invoices. There are many activities, particularly amongst the management and the staff groups, where it is very difficult to measure in the traditional sense of a numbers measurement system. But we're finding that it's still possible to measure, but in a slightly different way, in that having defined who your customer is, you go and then talk to your customer and find out if you're meeting his requirements.
By adapting the techniques and methods used to ensure the quality and overall efficiency of manufacture and assembly, and by applying them throughout their business, the Xerox Corporation are developing total quality into a strategy for managing their whole organization.
Step one, then, in the quality improvement process is to identify the output. Now, can you recall what the output was that we decided that we'd work on?
Yes, we were going to plan to produce a data book for the regional sales managers and the branch sales managers.
Okay, can I just check, Chris, did you already have a data book at that particular time?
Yes, indeed. We had a book which was that one here, but A, it was too big, and we felt it really wasn't meeting what they wanted, so we decided to try and improve upon it.
We did identify a range of customers that potentially would use, and we had to quantify whether, in fact, they would use it and what parts of the book they actually would use. So I think we aimed to go through the whole of the line management scene, from regional manager right down to branch commercial manager, to find out exactly what they wanted of us.
Right.
If you look at the book we had before, we had a massive data, not only summary sheets, but a lot of backup data. And what came out very clearly was they wanted the summary sheets, and they just wanted a name or a telephone number to go to someone who had the backup data who could explain it.
When I first came across quality, the focus seemed to be satisfying external customer needs, but we seem to be getting the impression very clearly that we all are customers of one another, and that's very important. If we can start to improve the way we work together internally, hopefully the end result is going to be external customers better satisfied.
The first thing that quality makes you do is sit down and say, what do you... It's called rather grandly a mission statement, but what it really means is, what are you there for?
Well, in the late 70s, Michelin recognised that the competitive environment was changing. We had a lot of products coming out of Japan and America that were significantly better than the products that we were manufacturing.
Xerox's emphasis over the last 20 years has perhaps switched more away from the shareholder towards satisfying the needs of the marketplace on a broader scale than it was doing before.
I think the concepts of quality are such basic common sense that you cannot avoid having them as a way of life in most businesses for the future.